The games of wiffle ball and baseball will always be connected in the sense that many of the rules apply to both, but from a physics standpoint, they are entirely different. For starters, the weight of a wiffle ball is only 1/3 of a baseball.
As for the bat is much thinner, and the balls are also different too. The baseball has seams on it, whereas the wiffle ball has several holes. These differences make for much different pitches and allow the wiffle ball to have movement that the baseball never could.
If you look at this pitch here, you can see that the ball is even with Henry's neck. You might think that the ball would stay even with his neck, but that would be incorrect. The holes in the wiffle ball disrupts the airflow as the ball is being thrown, which can cause the ball to do all sorts of crazy things. In this case, the ball proceeded to go straight down. The uneven pressure in the ball as a result of the holes, combined with the force of gravity pulling down on the ball, caused it to start in one spot and finish in an entirely different spot. Different types of movement depends on the way we grip the ball. When a pitch is being thrown, the only force acting on the ball is coming from the pitcher's hand. Different grips and curves put on the ball result in the ball taking on the effect that the hand exerts on it.
A well-thrown curveball with a wiffle ball has the ability to break up to 4 feet, whereas a well-thrown curveball with a baseball can only snap 12 to 14 inches. In order for a baseball to move as much as a wiffle ball does, it would have to be thrown at approximately 155 miles an hour, or the speed of wind in a Category 5 hurricane. Movement is so crucial to a wiffle ball pitcher's game because he will never have the same velocity that a baseball pitcher would have.
Here we have our wiffle ball and our baseball. The big difference here is the wiffle ball has holes on one side of it, where the baseball is perfectly flat around the entire side of it. Now, with the wiffle ball, what the holes do is it creates higher air pressure by allowing air to flow through the holes. What this does is it slows down the side with the holes on the ball. So say I throw the wiffle ball as hard as I can. It doesn't go that far. And then when I take the baseball, I don't have to throw it nearly as hard to throw it just as far.
Although you cannot throw a wiffle ball as fast as you can throw a baseball, the difference between the size of a baseball field and a wiffle ball field helped that problem. The distance between home plate and the pitcher's mound on a baseball field is 60 feet, whereas on a wiffle ball field, it's 42 feet.
This smaller field size still keeps the same difficulty. A 75-mile-an-hour pitch on a wiffle ball field is the equivalent of a 105-mile-an-hour fastball on an MLB field.
So that's the physics of wiffle ball.
I'm Henry.
I'm Jack.
I'm Kevin.
Goodbye.